Good morning, scholars. Today is Thursday, April 9th. I do want to start off this morning by giving some huge shout outs to scholars who got 100% yesterday. Yesterday was a pretty tricky lesson. I know I got a chance to help many scholars during office hours who had some just really great questions about their work, so we did not have a ton of 100%. UNC, sadly, 0 scholars scored a 100%. I'm sure we'll fix that for today. SCU, we had Adam, Aiden, Abimael, and Nevaeh. Nice work. And from Duke, we had Edwin and Dame. Really nice work. It was a very tricky lesson. In fact, we had so many scholars struggling. We're actually going to take some time today to review what we did yesterday. If you are a scholar who scored a 100%, I have a separate thing for you to do because I was just so impressed. So look for a message from me with separate directions. Everybody else, hang in there. We're going to work through some of these problems together and make sure by the end of today's lesson, we are all able to divide with decimals. All right, let's dive right on in. So similar to yesterday, we're going to start with a word problem. This is a problem about our friend Anira. So Anira is making biscuits. She decides she's going to make biscuits for the whole neighborhood. So she wants to make as many biscuits as she can. However, she only has 16 and 8/10 cups of flour. I don't know if any of you have been to the grocery store recently, but flour is one of those items that is just really hard to get right now. Every time I go to try to find flour, the whole flour shelf is wiped completely clean. So Anira only has 16 and 8/10 cups of flour. Now, each batch of biscuits that she wants to make calls for 3 cups of flour. So Anira needs to figure out how many batches of biscuits can she make to pass out to her neighbors. First thing we want to think about, even before our equation to model the story, is we want to answer this question of, can Anira make more or less than 16 and 8/10 batches of biscuits? Go ahead and just jot that down on your scrap paper. Can Anira make more or less than 16 and 8/10 batches of biscuits? Yep, you guys are exactly right. She can make less than 16 and 8/10 batches of biscuits because she only has 16 and 8/10 cups of flour, and each batch needs those 3 cups of flour. So she doesn't have enough flour to make 16 and 8/10 batches of biscuits. All right, so we know that Anira is going to be making less than 16 8/10 batches of biscuits. Go ahead and write your equation to model the story. All right, quick check in. We know that the equation that would match this story is going to be 16 and 8/10 divided by 3. If we take the amount of flour she has, we know she's putting 3 cups into each batch. And so this will tell us how many batches she can make. And we know that she will be able to make less than 16 and 8/10 batches. Next thing we need to do is we're going to estimate about how many batches of biscuits can she make. Go ahead and write it on your paper. I know everybody is writing along with me in order to estimate. This is where I can just drop that decimal right off because we're not going for an exact answer. We're just looking for an estimate. So I'm just going to chop off my decimal. This is very different from when we're actually dividing to get an answer. I'm just estimating. If she has about 16 cups of flour and each one needs 3, well, if I'm counting by 3s, 3, 6, 9, 12, 15. That is about 5. So she's going to be able to make about 5 batches of biscuits. A little bit more than 5, not quite 6, but that's about how many batches of biscuits she'll be able to make. All right, so we have our estimation down. The next thing we're going to do, and this is where some of us got a little bit tricked yesterday. So this is the most important time where we're following along. We are really focused. We're not watching this while doing other things in our room. We have our scrap paper, we have our writing utensil, and we are really focused because we know we need to be able to write equivalent expressions and divide by decimals. So our next direction is asking us to write an equivalent division expression without decimals and solve. I did post some anchor charts for everyone yesterday. I sent you guys a message as well, so you may have already checked those out, but let's go ahead and take a look, and I'll make sure you know where to find these. All right, when we are dividing with decimals, first thing we need to know is we need just some vocabulary that can help us talk about this division. We've learned this vocabulary before, but just as a refresher, if we had an expression such as 924 divided by 1 1/10, we know this first number, we refer to this as the dividend. I want everyone to say that, dividend. Your turn. Good. This is always the first number. This is the amount of things that we have that we are going to be dividing out. The next number in our division statement here, it's 1 1/10. This is called the divisor. My turn, divisor. Go ahead and say it. Good. So we have the dividend being divided by the divisor. Now, we know as fifth graders, we can write a division expression like this with the division symbol in the middle. We can also write it as a fraction, and it means the exact same thing because we know that this division symbol means exactly the same as this fraction bar. So I would read this 924 divided by 1 1/10, and we can read it as a fraction 924 divided by 1 1/10. When it looks like a fraction, we just call it a little bit, we just have some slightly different words. We're very familiar with these. We know the number in the top is our numerator, and the number at the bottom is our denominator. The numerator is exactly the same as the dividend, and the divisor is exactly the same as the denominator. Same number, just a slightly different way of thinking about it. If you are someone who loves fractions and you want to think of it as numerators and denominators, that's great. If you're someone who likes to write it out horizontally like this, you can think of it as the dividend and the divisor. Now, when we're dividing with decimals, we're going to be doing things to both the dividend and the divisor. Because we don't want to have to worry about dividing by tenths or hundredths or thousandths, our goal is to write an equivalent expression. Our goal is to write an equivalent expression. Go ahead and say that with me. Say equivalent expression. Your turn. Good. Don't be shy about talking to your video screen at home. That's how you learn these things so you can be really successful. So wherever you are, in your kitchen, in your living room, in your bedroom, outside, everyone is saying equivalent expression. Say it again. Good. Now, an equivalent expression, this is just a fancy way of saying a number sentence that is equal even though they look a little bit different. One classic example is our fractions 1/2 and 2/4. These would be examples of equivalent expressions. They equal the exact same amount. We could prove this and prove this and prove this. We could draw out 1/2. We could draw out 2/4. We know they are exactly the same. So they are equal, but they look a little bit different. These are called equivalent expressions. Exact same amount. If you have a pie and you eat 1/2 of it, or you have a pie and you eat 2/4 of it, you've eaten the exact same amount. And you probably have a tummy ache because that would be a lot of pie to eat. They're exactly the same amount. They just look different the way that they're written. So 1/2 doesn't look exactly the same the way we wrote it as 2/4. So when we want to solve a division problem that has a decimal in either the dividend or the divisor or both, our strategy right now is to actually remove the decimal point. Let's take a look at how we can do that. So to divide with the decimal in either the dividend, that's that first number, the numerator, or the divisor, that's that second number, or the denominator, first thing we're going to do, follow along with me, reading it from your screen, we're going to rewrite the division expression as an equivalent expression without a decimal point. Now, the most important thing to keep in mind, and where we got a little bit tricked yesterday, is I can't just move the decimal point in one number. If I do something to the dividend, I have to do it to the divisor. If I do something to the numerator, I have to do it to the denominator. This is no matter what it is I do. If I want to multiply by 2 or 4 or 10 or 15, no matter what I'm doing, if I do it to the dividend, I have to do it to the divisor. If I do it to the numerator, I have to do it to the denominator. So let's take a look. In this example, we have 924 and we want to divide it by 1 1/10. Yikes. I have a decimal here in my divisor. I want to take that decimal out. I cannot, I repeat, cannot just take out this decimal like I'm estimating and pretend it's not there. That only works for estimating. That doesn't give us an exact amount. I cannot, I repeat, cannot just move this decimal one place over and leave my 924 the same. It's not going to, those are not going to be equivalent. They're not equal to the same amount. If I do something to the dividend, I have to do it to the divisor. If I do something to the numerator, I have to do it to the denominator. We've known these rules about fractions for a long time. And so what I'm going to do to write this as an equivalent expression, I'm going to multiply both of my numbers by 10. We know that when we multiply by 10, we're just moving our decimal one place over to the right. And so when I multiply my 924 by 10, I'm moving that decimal over to the right. And because I have this hole here, I'm going to add a 0. That makes sense because we know when we multiply by 10, if we have a whole number, 924 times 10, I would just add that 0 to be 9,240. I did it to my dividend. I've got to do it to my divisor. So now that I have 1 1/10, I'm going to move that decimal point one place over by multiplying by 10, which now gives me 11. I have successfully gotten rid of the decimal point. I now have a new expression, 9,240 divided by 11. If it helps, we can think about the division expression as a fraction because we've already learned that if we multiply by something in the denominator, we have to do it to the numerator. Or if we do something to the numerator, we have to do it to the denominator. So if it helps, we can think of it as a fraction, 924 over 1 1/10. I want to get rid of this decimal by multiplying by 10 to move it on over. And so when I multiply by 10 in the denominator, I need to multiply by 10 in the numerator. Remember, if you do it to the divisor, you have to do it to the dividend. And so now I'm able to get 9,240 over or divided by 11. Whew, I have successfully created an equivalent expression. They're equal to the same amount. They just look different. Now I'm ready to divide. This goes back, scholars, to what we were doing way back when. Think back to November when we were dividing and we became experts at dividing. I know how to divide 9,240 by 11, easy breezy, mac and cheesy. And so I would finish up using my big 7 to divide. I finally get my answer of 840. 924, my dividend, divided by 1 1/10. My divisor is going to equal my quotient of 840. This anchor chart, we're going to be using it today. It's also posted in your Google Classroom, so use this if you need any help with the vocabulary or any help with the steps. All right, so let's go back to the problem we were just looking at. We have 16 and 8/10. Let's rewrite it so we have plenty of space. We're dividing by 3, and we need to complete the steps for dividing by a decimal. So here I have a decimal. I have a decimal in my dividend. Sometimes I might have a decimal in my dividend. I could have one in my divisor. I could even have one in both, but right now I have a decimal in my dividend. What I want to do is I want to write an equivalent expression, something that is equal to the same amount, but that looks a little bit different that will help me get rid of this decimal point. So what I'm going to do is I'm going to rewrite the division expression as an equivalent expression without a decimal point. I'm going to take my 16 and 8/10. I am going to multiply by 10, which will move that decimal over one place, which now gives me 168. But I can't just say 168 divided by 3. If I do something to the dividend, I have to do it to the divisor. If this were a fraction, if I did it to the numerator, I have to do it to the denominator. And so just like in our example, when we moved the decimal over in one number in our dividend, I have to do the same thing with my divisor. So now I'm looking at this number 3. I know that the decimal point is just right after the 3. Anytime we don't see it, we know it's right there. This is the same as 3 and 0/10, or 3.0. So I just need to move it over one place. And then anytime I have a hole like that, I just plug it in with a nice round 0. And so I have successfully written an equivalent expression. I turned 16 and 8/10 divided by 3 into 168 divided by 30. Now I am ready to divide to see how many batches of biscuits a Naira can make. Today as we work, we're going to have some problems that have remainders, and that's okay. We're not worried about what to do with our remainders right now. So if you get a remainder, totally fine. All right, next step says we need to divide. We are experts at dividing. So let's go ahead and divide 168 divided by 30. I'm just going to set up my big 7. You're doing this on your paper along with me. These notes are going to help you as you're solving your independent practice problems today. All right, so 168 divided by 30. Let's see, I'm just going to start by doing 30 times 4. I know that will get me to 120. Do some subtraction. Go ahead and subtract on your own. Again, you already have this on your paper. All right, I'm left with 48. I know 30 can go into 48 one time. So 30 times 1 gives me 30. I'm going to subtract. And I'm left with 18. Here, I recognize that 30, it's too big to go into 18. So I can't multiply by another whole. 18 is not quite half of 30, although it's pretty close. It's just a little bit more. If I were to multiply 30 by 1/2, that would give me 15. And I would have a little bit more. I'm not too worried about that right now. We can just leave it as a remainder. And as I look right here, I realize that a Naira can make 5 batches of biscuits. She can make 5, and I can say it's pretty close to 5.5, because if I were to do 30 times 1/2, that would give me 16. I still have a little bit more, but we can safely say that a Naira can make about 5.5 batches of biscuits. I'm not worried right now about solving it exactly to the decimal point. I can leave it just like this, and you'll be able to do this today as well. So a Naira can make about 5.5 batches of biscuits. If we go back and check our estimate, we estimated that she'd be able to make about 5 batches of biscuits. We were correct. We were able to solve this problem today by writing an equivalent expression in which we took the decimal point out of the dividend by multiplying both our dividend and our divisor by 10, moving that decimal point over on both of our numbers to create a new expression. Now, I don't want you to just take my word for it. We're actually going to do a little bit of proving, and for this, we're going to take out a calculator. So you can watch what I'm doing. If you want to write any of this down, you can. I want to prove that, in fact, 16 and 8/10 divided by 3 is exactly the same as 168 divided by 30. So I'm just going to find some room on my paper. We're just going to do a calculator proof. All right, first one I want to try is I want to go back and look at my original expression, 16 and 8/10. Divided by 3. All right, and when we want to see, is this going to equal the same thing as 168 divided by 30? This is what we came up with as an equivalent expression. I want to make sure those are actually equal to the same thing. So I'm going to take out my calculator. You can just watch as we type it. All right, I'm going to start with 100. I'm going to start with 16 and 8/10 divided by 3. And that gives me, 5 and 6/10. Yeah, we said it was going to be 5 and a half and just a teeny bit more. So 5 and 6/10. Now let's double check with our equivalent expression. I'm going to clear my calculator. And now I'm going to make sure that this is equal to exactly the same as 168 divided by 30. So I'm going to plug in 168 divided by 30. What are the chances? We got exactly the same thing, 5 and 6/10. I did, in fact, create an equivalent expression. Now, let's try another one. Let's see, is this the same as 168 divided by 3? We should already have a pretty good prediction about this, but what if we had just moved the decimal from our dividend and moved it over and left our divisor the same? This is what many of you did yesterday on your independent practice. You moved the decimal in one number, you didn't move it on the other number. Let's see what we get. 168 divided by 3. All right, thumbs up or thumbs down. Did we get the same thing? We didn't. The digits look kind of similar, but it's not the same amount. A Naira being able to make 5 and a little more than a half, or 5 and 6/10 batches of biscuits, is way different than a Naira being able to make 56 batches of biscuits. So these are not equivalent. It did not work when I only moved the decimal point in one number. And similarly, we could say, what if I left my decimal in my dividend and I did 16 and 8/10 and I divided that by 30. So here I just moved the decimal in my divisor and not my dividend. Go ahead and make a prediction. Do you think this will equal the same amount, those 5 and 6/10 batches of biscuits that a Naira can make? Let's see. 16 and 8/10 divided by 30 equals, did we get the same amount? We didn't. Again, the digits look similar, but this is very different. In this situation, Naira's not even able to make one whole batch of biscuits. It's like she can only make half a batch of biscuits. That's not enough biscuits for the whole neighborhood. That's not going to work, and it's not equivalent. So I'm going to cross this out as well as not being equivalent. In order to have an equivalent expression, I needed to move my decimal in both my dividend and my divisor. I needed to multiply both my numerator and my denominator by the same amount. All right, let's take a look at what we've been proving so far today. Here is our conjecture. This is written on your anchor chart. If it is helpful for you to jot this down, please feel free to add this to your notes. When dividing with a decimal in either the dividend, that's that first number, or the divisor, that second number, we can think of this as the numerator or the denominator, you can create an equivalent expression. This is when we make two expressions that equal the same amount, even though they don't look the same. So you can create an equivalent expression that doesn't have a decimal point as long as you do the same thing to both the dividend and the divisor, the numerator or the denominator. When we say do the same thing, what we mean is multiply by the same thing. If you multiply the dividend by 10, multiply the divisor by 10. If you multiply the dividend by 20, multiply the divisor by 20. If you move the decimal one place in the dividend, move it one place in the divisor. So just doing that same calculation or that same action to both the dividend and the divisor, both the numerator and the denominator. All right, we have already shown how this can work when dividing 924 divided by 1 and 1/10. You saw this on your anchor chart today. We saw how when we have a decimal, in this case, it's in our divisor. In order to divide, we're going to create that equivalent expression. So a number sentence that's equal, even though it looks different. We saw how we needed to move the decimal points in both the dividend and the divisor to create our new expression. And then we were able to divide. We've seen this in action. I want you to now try it on your paper. So find some blank space. Go ahead and copy down your problem, and I want you to try it by writing an equivalent division expression and then solving. I'm going to give you 4 minutes of work time. Go ahead and get to work. As a checkpoint, you should be done with your equivalent expression. So you should be ready with what expression is equivalent to 924 divided by 1 and 1/10. All right, if you're not done with your division, keep working, but let's check in with our equivalent expression. Using our resource right here, make sure you got the same equivalent expression. All right, take 12 more seconds. All right. Our equivalent expression should have been 9,240 divided by 11. I was able to remove the decimal point by moving it over one place in my divisor and one place in my dividend. This created an equivalent expression. And then I was able to divide, and I got to a quotient of 840. Let's just double check. In fact, we know that 9,240 divided by 11 equals 840 because we just solved that. Let's just make sure that 924 divided by 1 and 1/10 also equals 840. I just want to prove it. All right, let's do 924 divided by 1 and 1/10. And I get to that same answer, 840, that I do when I divide 9,240 divided by 11. They are equivalent. Because I moved my decimal point the same amount, I did the same thing to the divisor as I did to the dividend, I kept the equal amount. All right. It is time for some really fast drill. We are now going to practice writing equivalent expressions. We are not going to be solving these division problems right now. We are just going to be creating equivalent expressions. So find some fresh paper. Go ahead and number your paper. You can do A through F. So your scrap paper should look like this. Our task is going to be to see if we can create an equivalent division expression for each one of these division expressions without using a decimal point. Now, we already know I can't just take out this decimal point. 97 and 4/10 divided by 8 is not the same as 974 divided by 8. We have to do the same thing to the dividend that we do to the divisor. You have another resource that you can be using today that's also posted in your Google Classroom just about equivalent expressions. It's just a reminder that an equivalent expression is a number of sentences that are equal even though they look different. Here my example is 1/10 is equal to the same amount as 10 100ths. They just look a little bit different. But I could turn my 1/10 into 10 hundredths by just multiplying my numerator by 10 and my denominator by 10. They stay equal to the same amount. I'm going to leave up these examples of equivalent expressions where you can just see how in each example we were moving the decimal point in both the dividend and the divisor to create those equivalent expressions. So I'm going to leave this chart up for you. I'm going to put back up your problems. We're going to do the first one together and then see how many you can get on your own. So go ahead and write down your very first problem, 97 and 4/10 divided by 8. equals, and we're not solving it right now. We're just writing that equivalent expression. This is how I set it up on my paper. And as I go back and look at my example, I see that I need to move the decimal point in both of my numbers, both my dividend and my divisor. So I want to move this decimal point over so I'm no longer dealing with a decimal point. I'm going to move that over one spot, which will give me 974. My 8 doesn't have a decimal point. I can't just leave it the same. I know a decimal point is really after the number if I don't see it. When I move it one space over, fill up that hole with an 80. That makes sense because 8 times 10 is 80. And so my equivalent decimal expression would be 974 divided by 80. That's all I'm going to write. I'm not going to solve it right now at all. All right, let's see how many you can get. I'm going to put up both your division expressions and this chart for you to use. Let's see how many we can get done in, let's say, 3 minutes. You should start to see this pattern pretty quickly. Go ahead and get to work. All right, final minute. See if you can finish all of them. Final 30 seconds. If you're done, you can grab a pen or a marker or something to check your work. All right. Let's see what we got. See how we did. Have something out so you're ready to check your work along with me. All right. Letter A, we already did that one together. Our equivalent expression should be 974 divided by 80. Give yourself a check if you got that one. Letter B, you should have gotten 1013 divided by 120. Check or X. Letter C, 460 divided by 16. Cha-ching if you got that correct. Letter D, 9,040 divided by 2. Go ahead and give yourself a check if you got that one correct. Don't get tricked. This is one where some of us like to turn that 2 into a 20. That's too much. I'm only moving it one space over. Letter E, you should have gotten 1,360 divided by 42. Cha-ching, if you got that correct. And F, this had a decimal in both the dividend and the divisor. Shouldn't have made a difference. We moved both decimals over one place, and we got 193 divided by 52. Nice work. Go ahead and total up the amount you got correct. I got 6 today. I'm crushing it. See how many you got as well. All right, I think we're getting a lot better at writing equivalent expressions. Next thing we're going to do is we are going to now take it one step further. And now we're actually going to write an equivalent expression and then solve. So remember, after we create our equivalent expression, then we actually divide, because this is how we answer the question of how much is 225 divided by 2 and 5 times. All right, we'll try the first one together, then you can try the rest on your own. Go ahead and find some room on your paper, and let's go ahead and set up letter A by writing down the problem. 225 divided by 2 and 5 tenths. All right, should be set up on your paper, just like mine. If we go back and look at our steps to divide with decimals, the first thing we need to do is we need to create an equivalent expression. We just practiced this a ton. Go ahead and write your equivalent expression. I want to move this decimal over. I need to move it over in both my numbers, so my new expression is 2,250 divided by 25. I know these are equivalent because I multiplied each side by 10 to move that decimal over one place in both my dividend and my divisor. Now I'm ready for step 2. Now I'm ready to divide. Now I'm going to set up my big 7. You're doing this on your paper as well. 2,250 divided by 25. All right, go ahead and solve this and we'll check in and see what we got. Excuse me. All right, take 30 more seconds to finish it up. All right, after I did all that division, I got to an answer of 90. If you also got to an answer of 90, you are correct. So 90 was my answer to 2,250 divided by 25, but we know these are equivalent. So that's also my answer to 225 divided by 2 and 5 tenths. They are equivalent. So both of those equal to 90. That is how I was able to solve. I hope everyone wrote this one down. You may see this question again. Hint, I hope everyone wrote this down. You may see this question again. All right, a couple more to try. Go ahead and get started on B, C, and D. We'll take 5 minutes of work time and then we'll come back in and check. As a reminder, this is the time to be doing the math. This is how you'll know what to do on your independent practice by practicing it along with me, checking in your answer. So everybody is writing. Go ahead and get to work. Remember, if you get a remainder, that's totally okay. Final minute. Make sure you have an equivalent expression. And a quotient for each one. final 20 seconds. All right, let's check in and see what we got. Go ahead and check your paper along with mine. For problem B, we were doing 56 divided by 7/10. Our equivalent expression was 560 divided by 7. If you got that part correct, give yourself a check. We got that by moving the decimal point one place over in both our dividend and our divisor. When I divided that out, that one was quick for me because I knew that 7 times 8 is 56, and so I was able to quickly get to 80. So my answer, 56 divided by 7/10, was 80. If you got an answer of 80, go ahead and give yourself a check. One check for your equivalent expression and one check for your correct answer. Let's take a look at C. Here we had 12 4/10 divided by 2. When we rewrote it as an equivalent expression, we had 124 divided by 20. We got that by just moving the decimal point over in both our dividend and our divisor. Give yourself a check. This one had a remainder. I did 20 times 6, which got me to 120. It left me with 4. I'm not worrying about that right now. I got to an answer of 6 with a remainder of 4. Cha-ching if you got that correct. And finally, question D. Here we had 24 8/10 divided by 6 2/10. 2 decimal points, but we didn't get tricked. We moved the decimal point over in both numbers, which gave us 248 divided by 62. When I solved that, so first give yourself a check if you got the correct equivalent expression. And again, we did not have to add any zeros this time because we just moved each decimal point over one spot. When I divided that out, I did 62 times 2. I didn't know that right off the top of my head, so I did some quick addition on the side. Got to 124. Did that twice, which gave me an answer of 4. If you got 4, a lovely check. Another total of 6 points. If you got all 6 correct, make sure you're putting a big fat 6 at the top of your paper, and then also drawing yourself a huge smiley face with a gorgeous hat for all of your hard work. Yesterday, we were not able to write equivalent expressions and divide decimals. Today, we are. I am so impressed with the hard work you put into watching this video, completing the math along with it. I want to make sure you are ready to do oh so well on your independent practice today. So a couple really important announcements. Make sure you're listening really carefully. First thing, I want to show you what it's going to look like today. Yes, this is yesterday's practice. This is the one that most of us not our hottest score in math. I want to make sure we know exactly how to answer this. Let's take a look at question number 1. Select the expression that shows an equivalent division expression without decimals for the problem 36 2/10. I would go over to my scrap paper. I would write on my scrap paper 36 divided by 0 2/10. And then I would solve it myself to see which one matches. I would move my decimal point over in my 2/10. I would move it over in my 36. And so then I would rewrite on my paper that this is the same as 360 divided by 2. I could then go back to question 2, and I'm seeing which one matches 360 divided by 2. It's right there. And I'm going to select choice B. All right, then I would take a look at question 2. Question 2 is asking me to just solve that. It wants me to solve 36 divided by 2/10. Well, I already know that an equivalent expression for 36 divided by 2/10 is 360 divided by 2. So I'm going to use this without any decimals to go ahead and solve. Let's see. Oh, I know, 2 times 18 is 36. 2 times 180 would be, 360. For an answer of 180. So then I would go and I would type in my answer for number 2 of 180. On question number 3, I'm going to do the same thing. Select the expression that shows an equivalent division expression. We talked a lot about equivalent expressions today, but I want one without decimals for the problem 864 divided by 1 and 2/10. So I'm going to rewrite this. 864 divided by 1 and 2/10. I'm going to move my decimal point over in my divisor, which means I need to move it over in my dividend. I'm going to rewrite my new expression. And I'm getting 8,640 divided by 12. I would then go check my options. 8,640 divided by 12. I can see where there's some tricky choices in there, but I already solved it, so I'm checking what I have with what I see right here. Question 4 is just asking me to solve that. Great. I already know what the equivalent expression is, so now I'm just going to set up my big 7 to solve. That's what we should have seen on yesterday's independent practice. Listen really carefully because this might be helpful to some of you. If you would like to redo yesterday's practice because you are not happy with your score, remember all of these do go in your grade book and count toward your final grade for that math grade in 5th grade. If you would like to redo it, all you need to do is when you turn in today's work, send me a message that you want to redo it, and I will reopen it for you. I actually just gave you all of the correct answers, so I should see lots of hundreds. That can really help your grade out. So I'm not going to grade them yet. I'm going to wait until the end of the day today, and if you would like to redo it, you are more than welcome to. I will be thrilled if you want to redo it. You will just need to send me that message. So let's take a quick look at today's practice. You saw what it should look like yesterday. Same idea today. You're selecting the expression that shows an equivalent division expression. Make sure you're solving it on your paper so you can pick the best one, and then you're just solving that same problem using that equivalent expression. So your tasks for today, you are almost done watching this video. Nice focus. The first thing you're going to do is your April 9th independent practice. This is just divide decimals round 2. When you are done with this and you're ready to submit it, just send me a message as you're submitting it and say, Ms. Alperin, I would like to redo yesterday's work. I'll open it up for you again, get a fresh start. I already gave you all the answers, and you can get 2 100s. All right, really excited to see some increased scores going in to today. Thank you for all your great focus and all of your hard work.